Ninja. If I look at multiplying two
That's not that weird.
if I multiply, just a little side note here. Somebody posted on Facebook, what up, my ninjas? I'm like, people commented on that, and then finally I said, shh, you're not a very good ninja.
Okay, I didn't get that.
If you're a ninja and you bust up to everyone like, what up, my ninja? It's like, dude, you're the worst ninja ever.
Oh.
It's like trying to play quiet mouse, still mouse with a really loud kid. Did I win yet? No, dude, you lost again. Like I didn't even get to start the game. When you multiply two polynomials, each term in one polynomial will multiply times every term in the other polynomial. So each term in one polynomial multiplies times each term in the other polynomial. Okay. Now, think about it this way. If you're on a sports team and you're competing against another team, you know that either before or after the game you have to shake everybody's hand, right? Or high fives, or just like the whole good game, yeah, right, and just kind of keep going on, right? That's what we're doing here. Everybody in one polynomial shakes hands with everybody in the other polynomial. You don't need to shake your own teammates' hands, right?
Yeah, you do.
That's just good.
People that didn't play, you have to shake their hands too.
Okay, that's called junior varsity. The ones that don't play. We're not talking about those guys. Now, so let's just take this example right here. Tosh and Mariah, you're on this row, like what's up? You don't need to shake each other's hands because you see each other, every day next to each other, right? Just like you, Angie, and Boris, you see each other. Now, suppose you want to introduce yourself to the other team. Okay, so Tosh, you'll shake Angie's and Boris's hands, right? And then Mariah will shake their hands as well. That's what's going on here. Now, if you shake both their hands and she shakes both their hands, Angie, do you need to shake their hands a second time? Because you would have already shaken both their hands, right? That's what's going on in this. Let me give you an example so you can kind of see this guy. This is what goes on in my mind. I see these guys as people. These are my friends. I've got pictures in my wallet of them. 2x plus 7 times 3x minus 5. Okay. What I want to do is I want to make sure that this 2x multiplies times everybody over here. Right? And once he's done multiplying, then it's 7's turn to go over. Huh? Opposite?
No, I didn't say that.
Oh, well, I'm hearing all kinds of crazy things. So this is one way of writing this out. You're doing 2x times that group 3x minus 5, and you were also taking 7 times that same group 3x minus 5. Okay? Now there are several ways for multiplying polynomials, and we're going to go through all these different ways. You pick whichever one works best for you. It's all about how you organize your product, how you organize the terms. So when I multiply this stuff, what do you get when you do the distributing?
6x squared.
6x squared, good. Then what? Minus 10x, keep going. Plus 21x minus 35. Am I done?
No, it's a combined like terms.
You combine like terms, just like your mama taught you, right?
So it'd be 6x squared
6x squared
plus 11x
plus 11x minus 35. Now this is not the only way for organizing your terms, and in fact doing it this way can oftentimes get messy when your polynomials are larger. Now some people, I was shown this after I already had my degrees, which means don't ever stop learning. Had a student show me this. They said their teacher showed them this thing called the box method. Now, all the box method does is it takes the problem and just organizes things differently. And it uses, guess what? A box. Now here's how you would set it up. You would take one of the polynomials in the product, say 2x plus 7. Put that on top of a box that we're going to draw. And on the side, you're going to put the other polynomial, which in this case is 3x minus 5. And what this box is going to do is going to organize your terms. Okay. So inside the boxes, you put the smaller products, the products of the individual factors. So in this first box, just look at it this way. What's in that first box? What's the product there?
6x squared.
Okay.
Me too. It looks familiar.
Science. Yeah.
Science?
Yeah, you know.
The Punnett square.
Yeah,
A Mendeleev?
yeah. It's something like that.
Yeah, I got you. So, and then do this other product. What's 3x times 7?
21x.
Positive 21x, right? And then keep working down here. What happens down here? Negative 5 times 2x is negative 10x, and then what?
And then negative 35.
Negative 35. Now, I want you to see something. See this row right here, the 6x squared plus 21x? You see these same two terms right here. And then the negative 10x minus 35 are these two terms right here. So it's all the same terms. The order may look just a little bit different, right? Now, whoops, excuse me. But you see all the terms are the same. There's your 6x squared, your minus 10x, your plus 21x, and your minus 35. And so the answer that you get here is the same that we had the first time. And what you're going to see a lot of times when you use this box method is that your like terms tend to line up on the diagonals, like that. So I get 6x squared plus 11x minus 35. The same answer I had before.